Artemis I. Artemis I marked the beginning of NASA's return to deep space exploration after more than 50 years. Following the end of the Apollo program, astronauts remained in low Earth orbit aboard spacecraft like the Space Shuttle and the International Space Station. While those missions advanced science and technology, NASA's long-term goal was always to venture farther into the solar system again. Artemis I was the first major step toward making that goal a reality. The mission launched on November 16, 2022, from Kennedy Space Center in Florida. Powering the mission was the Space Launch System, or SLS, the most powerful rocket NASA had ever built. Sitting on top was the Orion spacecraft, a completely new crew capsule designed to carry astronauts farther from Earth than any modern spacecraft before it. Unlike later Artemis missions, Artemis I carried no astronauts. Instead, the spacecraft was filled with sensors, cameras, and 3 test mannequins. These mannequins wore special suits equipped with instruments that measured radiation, vibration, and acceleration during every stage of the flight. The information they collected would help engineers improve astronaut safety before anyone boarded Orion. After leaving Earth, Orion traveled toward the Moon before entering a distant retrograde orbit. This unusual orbit allowed the spacecraft to remain stable while venturing farther from Earth than any spacecraft designed for humans had ever traveled. At its greatest distance, Orion flew more than 430,000 kilometers from Earth, demonstrating that it could safely operate in deep space for weeks. Throughout the 25-day mission, engineers carefully monitored every important system. They tested navigation, communications, propulsion, electrical power, thermal control, and life support hardware intended for future crews. Even though nobody was inside Orion, nearly every system that astronauts would eventually depend on was operating throughout the mission. One of the biggest challenges came at the end of the flight. Orion returned to Earth at nearly 40,000 kilometers per hour, making it one of the fastest spacecraft ever to re-enter Earth's atmosphere. The heat shield endured temperatures approaching 2,800 degrees Celsius while protecting the capsule inside. Orion also performed a skip re-entry, briefly bouncing off the upper atmosphere before descending again. This technique reduces stress on the spacecraft and helps improve landing accuracy. On December 11, 2022, Orion splashed safely into the Pacific Ocean, completing a highly successful mission. Artemis I proved that both the Space Launch System and Orion were ready for astronauts, giving NASA the confidence to proceed with the first crewed mission of the Artemis program, Artemis II. Artemis II became the first crewed mission of the Artemis program and the first time humans traveled beyond low Earth orbit since Apollo 17 in 1972. After years of testing, NASA was finally ready to place astronauts aboard Orion and demonstrate that the spacecraft could safely carry people on a journey around the Moon. The mission launched aboard another Space Launch System rocket from Kennedy Space Center. Inside Orion were 4 astronauts, representing both NASA and the Canadian Space Agency. Their international crew reflected one of the defining features of the Artemis program, bringing together multiple nations to explore deep space. Unlike the Apollo missions that aimed directly for a lunar landing after early testing, Artemis II focused entirely on proving the transportation system with astronauts on board. During the journey, the crew tested Orion's navigation systems, communications equipment, environmental controls, life support systems, and manual flight capabilities. Every procedure helped engineers confirm that the spacecraft performed as expected under real operating conditions. As Orion traveled toward the Moon, the astronauts became the first humans in more than 5 decades to leave Earth's immediate neighborhood. They witnessed views that only 24 people in history had ever experienced, including the far side of the Moon, a landscape permanently hidden from observers on Earth. After completing a lunar flyby, Orion began its journey home. The spacecraft once again faced the extreme challenge of atmospheric re-entry, relying on its heat shield to survive the intense temperatures created by its enormous speed. Following a successful splashdown in the Pacific Ocean, the crew returned safely to Earth, completing a mission that demonstrated the entire Artemis transportation system was ready for increasingly ambitious exploration. The success of Artemis II represented much more than another spaceflight. It showed that humanity had officially returned to deep space travel and was once again preparing for missions that would place astronauts on the lunar surface and eventually send humans toward Mars. Artemis III. Artemis III is currently planned as the next major step in NASA's revised exploration strategy. Rather than immediately attempting another lunar landing, the mission is intended to demonstrate and validate several new systems that future moon landings will depend on. This updated approach reflects NASA's decision to reduce technical risk by testing critical hardware before committing astronauts to a surface mission. The mission will again use the Space Launch System to launch Orion into space with a crew aboard. During the flight, astronauts are expected to evaluate next-generation technologies, including including upgraded spacesuits and the systems that will support future lunar landers. Engineers want to ensure these new designs operate safely under real space conditions before they are used during a landing mission. Another important objective is to strengthen cooperation between Orion and the spacecraft that will eventually transport astronauts from lunar orbit to the Moon's surface. Testing these systems separately allows engineers to identify potential issues early, making future missions safer and more reliable. Although Artemis III is no longer expected to include a moon landing under NASA's revised plan, it remains one of the program's most important missions. Space exploration has repeatedly shown that careful testing often prevents failures later, and NASA has chosen to prioritize long-term success over rushing back to the lunar surface. By the end of Artemis III, NASA expects to have validated the key technologies needed for sustained human exploration around the Moon. Those achievements will pave the way for Artemis IV, which is planned to return astronauts to the lunar surface and begin a new era of exploration, unlike anything accomplished during the Apollo program. Artemis IV. Artemis IV is planned to become one of the most historic missions of the entire Artemis program. Building on everything learned from the first 3 flights, its primary goal is to return astronauts to the Moon and begin a new era of sustained human exploration. Unlike the Apollo missions, which focused on short visits, Artemis IV is designed to support a long-term presence that will prepare humanity for even deeper journeys into the solar system. The mission will launch aboard an upgraded version of NASA's Space Launch System. At the top of the rocket will be the Orion spacecraft, carrying astronauts toward lunar orbit. Waiting there will be the systems needed to support the landing mission, allowing the crew to prepare before descending to the surface. The landing is expected to take place near the Moon's south pole, one of the most scientifically valuable regions ever explored. Unlike the Apollo landing sites near the lunar equator, the South Pole contains mountains that receive sunlight for most of the year, alongside craters that remain in permanent darkness. Scientists believe these shadowed craters contain water ice that has remained frozen for billions of years. Finding and studying this ice is one of the mission's highest priorities. Water is far more valuable than simply providing something to drink. It can be separated into hydrogen and oxygen, creating breathable air for astronauts and fuel for future rockets. If explorers can produce these resources directly on the Moon, future missions will no longer need to launch every supply from Earth. The astronauts are expected to spend several days exploring the surface. Wearing advanced lunar spacesuits, they will collect rock samples, drill beneath the surface, deploy scientific instruments, and map areas that have never been visited by humans. Modern navigation systems, improved communications, and more capable equipment will allow them to accomplish far more than the Apollo astronauts could decades earlier. The mission will also continue testing technologies needed for future lunar habitats. Engineers want to understand how equipment performs during long exposure to lunar dust, freezing temperatures, intense sunlight, and constant radiation. Every successful test brings scientists one step closer to building permanent infrastructure on the Moon. Although the mission itself may last only a few weeks, its impact could shape space exploration for decades. Artemis IV is expected to prove that humans can not only return to the Moon, but also begin learning how to live and work there for extended periods. Artemis V. Artemis V is expected to continue expanding human activity on the Moon rather than simply repeating previous missions. By this point, NASA hopes lunar exploration will become more regular, with each mission building directly upon the discoveries and infrastructure created by earlier crews. One of the mission's major objectives is expected to be another landing near the Moon's south pole. Returning to this region allows scientists to compare observations from different locations while expanding their understanding of the Moon's geology and resources. Instead of exploring only a small area, astronauts will gradually build a much more complete picture of the lunar environment. Future crews are expected to travel farther across the surface using improved vehicles capable of carrying astronauts and scientific equipment over much greater distances. These lunar vehicles allow researchers to investigate areas that would be impossible to reach on foot, greatly increasing the amount of science completed during each mission. Artemis V will also continue studying lunar water ice and other useful materials found in the soil. Scientists hope to demonstrate that local resources can support future explorers by producing water, oxygen, construction materials, and possibly even rocket fuel. This approach, known as in situ resource utilization, could completely change how future space missions are planned. Another important goal is improving the systems that keep astronauts alive during extended stays. Engineers will continue evaluating power systems, communication networks, life support equipment, and habitats designed to protect crews from radiation, extreme temperatures, and abrasive lunar dust. Every improvement makes longer missions more practical. Scientific research will remain at the heart of the mission. Astronauts are expected to deploy new instruments that continue collecting data long after they leave the Moon. These experiments may monitor moonquakes, measure radiation levels, study the lunar interior, and observe changes in the environment over many years. By the conclusion of Artemis V, NASA hopes to demonstrate that human exploration of the Moon is becoming sustainable instead of temporary. Rather than treating every landing as a separate achievement, the Artemis program aims to establish a continuous cycle of exploration, scientific discovery, and technological advancement that prepares humanity for its next great destination, Mars. Artemis VI. Artemis VI is expected to build on everything accomplished by the earlier missions and move even closer to establishing a continuous human presence on and around the Moon. While NASA has not yet released the complete mission plan, the long-term goals of the Artemis program provide a clear picture of what this stage of exploration is expected to achieve. By this point, many of the transportation systems, landing vehicles, and surface equipment should already be well tested, allowing astronauts to focus more on science and long-duration operations. One of the mission's biggest priorities is likely to be extending the amount of time astronauts can safely remain on the lunar surface. Earlier, Artemis crews are expected to spend only several days on the Moon, but future missions will gradually increase the length of each stay. Longer expeditions allow scientists to conduct more detailed research, travel farther from the landing site, and test technologies under conditions that closely resemble future missions to Mars. The harsh lunar environment continues to present many challenges. During the lunar day, temperatures can climb above 100 degrees Celsius, while permanently shadowed craters remain colder than many places in the outer solar system. There is no breathable atmosphere, no weather to remove dust, and almost no protection from radiation coming from deep space. Artemis VI will likely continue evaluating habitats, power systems, and life support equipment that can withstand these extreme conditions. Astronauts are also expected to expand the scientific network left behind by previous missions. New instruments may be installed to measure moonquakes, monitor radiation, study the Moon's thin exosphere, and observe changes beneath the lunar surface. Unlike short-term experiments, these stations could operate continuously for years, sending valuable information back to Earth long after the astronauts have departed. Another important objective will likely involve improving the use of local lunar resources. Scientists hope to extract larger amounts of water ice from permanently shadowed craters and refine technologies that separate water into hydrogen and oxygen. Success in this area would reduce dependence on supplies launched from Earth and make future exploration much more practical. The mission may also test improved robotic systems capable of working alongside astronauts. These robots could transport equipment, inspect landing sites, perform maintenance, or even begin preparing locations before humans arrive. Combining human decision-making with robotic efficiency allows crews to accomplish much more during every expedition. Every achievement during Artemis VI brings NASA closer to its long-term vision of making the Moon a permanent destination for scientific research and a stepping stone for even deeper exploration.